Parametric curves, video number 4. We were finding the second derivative, and we still have to multiply the I still have to multiply the y dot times x2 dots. Let me do something. Let me do something. Instead of looking here, let me take this to underneath that. Okay. All right, and now we can continue, right? First, I'm multiplying y2 dots. This is easier now. Y2 dots by x dot. The answer directly is minus sine square pi minus t. Now I have to multiply y dot by x 2 dots. Y dot by x 2 dots. This is x 2 dots. So up there, this is x 2 dots, right? I have to multiply these two values. It will be plus cosine square pi minus t, and we have minus already here, so it's minus cosine square pi minus t over x dot square, x dot cubed. X dot is sine cubed of pi minus t. The answer will be minus into sine squared pi minus t plus cosine squared pi minus t over sine cubed pi minus t. Now, what does that mean, right? The numerator will be minus 1, and the denominator is sine cubed pi minus t. Since it's a cubic value, and the denominator is minus 1, so the sign of the y second prime, y double prime, it depends on the sign of sine pi minus t. If sign of sine pi minus t negative, then the second derivative will be positive, because we have minus 1 in the numerator, and if it is positive, it will be negative. Let's see. If t between 0 and pi, because this is t, between 0 and pi, right? If t between 0 and pi, what will be the sign of the curve? Between 0 and pi, the sign from 0 to pi, both places, all students, the sign is positive. This means that denominator is positive and the numerator is negative. This means y double prime in this case is strictly negative over all the domain of t, right? Over all the domain of t, excluding 0 and pi, because these are special angles, make the sign negative, right? Sorry, makes the sign positive, 0, not negative, not positive. It will be 0 in the denominator, so exclude these values. Now, what we do is the curve here, we know that the curve just concave at this domain, it concave downwards. And that's it. We're done. Now how we draw? Let's draw. First, let's put the x-axis and the y-axis. Okay, this is the y-axis, this is the x-axis, and let's put the values. We should have, it's simple, the endpoints first. Minus 1, 0, 1, 0. Minus 1, 0 is one of the most important points. It's an endpoint. This is minus 1, 0, and this is 1, 0, let's say. And you know now, the curve looks like what? Let's see if it should intersect the y-axis, right? At which point? Do we have another point we have to worry about? We might have it. No. So let's, if we can say that x equals 0. Okay. If x is 0, this is minus 1, 1, where t is what? Let's go back. This is minus 1, 0, where t is 0, and 1, 0, where t is pi. So here the t is 0, and here the t is equal to pi. So we still have where t is pi over 2. Look at that. If you put t pi over 2, pi minus pi over 2, it's pi over 2. Cosine pi over 2, 0, so x is 0. And pi over 2 here, pi minus pi over 2 is pi over 2. Sine pi over 2 is 1, so the y is 1. So we have a point 1, 0. It's faster than we do it as usual. We have 1, 0 here. And this for t is pi over 2. This is for t0. Sorry, this is for t0. This is for t pi over 2, and this is for t pi. And we draw our curve, which is concave downwards. And look, from t0 to t pi over 2, go again to the first derivative. From t0 to t pi over 2, the derivative was positive. This means it's increasing function. And from t pi over 2 to t pi, from t pi over 2 to t pi, the derivative was negative, so it is decreasing function. That's correct. It's going downwards. So it goes upwards first, and then it goes downwards. From left to right, again, it goes upwards, then it goes downwards. And the concavity is downwards, right? Concavity. So this is the figure. And this video also is done.